In Chapter 11, we have two different types of sequences. We have sequences that are arithmetic, and we have sequences that are geometric. So arithmetic sequences are sequences that increase or decrease by the same amount. That's called the D. That's called the common difference. So to find the common difference, what you want to do is you want to do the second term minus the first term. Okay, so difference comes from subtract. Okay, so difference in math means subtract. And then geometric, we have our R, which is called our common ratio. So just like for the arithmetic, you do the second term minus the first term. Ratio means divide. So what you're going to do is find the second term, and you're going to divide it by the first term. So both of these have explicit formulas. So explicit formula is what you want to use if you're trying to find the 12th term or the 15th term and you don't know the number before, you don't know the term before it. So explicit formula for arithmetic would be a sub n. So that means give me the nth term is going to be a sub 1, which is write down the first term, plus n minus 1. So if you're trying to find the 40th term, you plug in 40. So a sub 40 would stand for the 40th term, times d. So d is the common difference. That's explicit formula for arithmetic. For geometric, it's a sub n equals the first term times r to the n minus 1. So I put r in parentheses because remember, if you're squaring a negative, it turns to positive if it's in parentheses. If it's a fraction, you want to make sure that the exponent gets the numerator and denominator. So that's the explicit formula. We also have the recursive formula. So the recursive formula is used if you're given the previous term. So the recursive formula is 2 lines. So that is a sub 1 equals a sub 1. So you have to give somebody the first term. And to get the nth term, you need to take the previous term. So a sub n minus 1 means the term before n. So you have to take the previous term and then add the common difference. That's very similar to over here, the geometric sequence. You still need to put the first term in, and then to get the next term, or to get the nth term, you take the previous term and you multiply it by r, because it's geometric means to multiply to get the next term. So recursive formula and explicit formula, you need to plug in the a1 and the d. So you keep everything else around it the same. Okay, everything else around it is the same, but you need to plug in your a1 and your r as a number, your a1 and your r as a number. So it's important that you have those. Just like it's if you're writing it in slope-intercept form, you keep the y and the x, and you need to get the m and the b. It's the same thing. So here's how they're similar. Now, when you have a series, remember a series is when you add the numbers in a sequence. So the only series that you can add that's arithmetic is a finite series. Okay, so the formula to add n number of terms in an arithmetic series or sequence is s sub n equals n, which is the number of terms, over 2 times the first term plus the last term. Sometimes you're going to have to use the explicit formula to get this nth term. Okay, so if you'd find the first 40 terms of an arithmetic series, this would be 40, 40, and this would be the 40th term. So you might have to solve using the explicit formula to get the 40th term. Now, in a geometric series, you can have a finite geometric series. So that means that the series stops. In that case, you're going to use the formula a sub 1 times 1 minus r to the n over 1 minus r. And the biggest mistake I see that people make is just not putting this right in their calculator. So I always put parentheses around the numerator and denominator. You can also have an infinite series. And to figure out if it converges or diverges. So converges means it has a sum. And so infinite, you can either have it diverge. Diverge means it doesn't go to a certain number. It doesn't have a sum. You just keep adding them up, and the number goes to close to infinity or negative infinity. And that is if the absolute value of the number, the common ratio, is greater than or equal to 1. It diverges. It will converge, which means it will have a sum if the absolute value of r is less than 1. So that formula, if it has a sum, if it converges, if your r is less than 1, the absolute value of it is a sub 1. So a sub 1 over 1 minus r. So those are the differences and the similarities between an arithmetic and geometric sequence. You have an explicit formula for both. You have some type of common thing for both. You have a recursive formula. You have series. You have one formula for arithmetic and two for geometric, dependent on if it's finite or infinite.